Right. Cool. Wow, that's a great turnout. How's everybody doing today? Everyone good? Woo! Cool. All right. Hi, everybody. Welcome to the Q3 Kubernetes CNCF East Canada Meetup Toronto chapter. Really glad to have everybody here at the ecobee office. Really nice to see everybody together. It feels like it's been a while since we all got into the same room, so awesome. Welcome. We have a jam-packed agenda for you all tonight. We're going to start with our usual event introduction and housekeeping. Then we've got three great talks for you. Not one, not two, but three great talks. We've got how to build cloud-native event-driven applications with Knative. That's Cilium and Leo. If you guys want to put your hands up, there's Cilium and Leo. We've got translating troubleshooting skills from baking to software. That's Adriana and a special guest. And to round things out, we've got what's smoother than your morning espresso poll? Bridging gaps with BGP and Cilium over here with Marino. Cool. I'm your host, Jason Hattie. I work here at ecobee. I'm an SRE, and really happy to have you all here tonight. So again, here's our speakers. I should have probably went to this slide, but you'll be hearing from them tonight. So just some housekeeping here. We got a great turnout tonight, so that means you found our event somehow, one way or another. If you found it by chance, you can find it reliably by going to our link tree here. This has all our events, whether you're in Toronto or you're in Montreal or Quebec City or Ottawa. This is how you can stay connected to us. You'll find all of our socials there, and it's probably the easiest way to get a hold of us. So you'll find a link there to our Slack channel. That's where you'll find a bunch of us from the community. You can ask great questions about Cube or any CNCF tech. I just love to chat there. So take a picture, come back later, and here's how you can find our stuff. Probably one of the easiest ways. Thank you to our host, ecobee. Ecobee is a strong user of CNCF tech. We use Kubernetes like a lot of you all, but so much more, gRPC, Envoy, so many CNCF things that just make our lives amazing, right, from the technology perspective. So ecobee employees, just put your hands up if you're around. There's more downstairs, I think, shepherding the latecomers. But we'd love to chat. And if you have questions about what we do, what we make, we'd love to answer them. So be remiss to mention that we are hiring. If you don't know what we do, you might know us about our smart thermostat. That's sort of our claim to fame, first internet connected thermostat. But now we're building more than that. We have smart security solutions and really just trying to be build the helpful home, trying to be a smart assistant in all of that. So what we do matters. We build comfort and efficiency and peace of mind, but it also helps, build a better green place in the world. There's a lot of things here at ecobee for employees if you do want to join. There's all these benefits around flexible work engagements, working from home, parental top-up, 25-day paid sabbatical after 5 years. Let's brigade budget for personal development. Lots of benefits for our employees. So you can definitely come here and grow and do amazing things. Here are our current job openings. You can take a picture of this. Come speak to any of us here at ecobee. Happy to talk more about the roles and what we do. And if you want to check us out later, you can go to www.ecobee.com/careers. That's ecobee.com/careers. Thank you to our sponsors. Our meetup does have some sponsors, so thank you to Sysdig and JFrog for being sponsors of our meetup. They help pay for things like pizza and beer and help us really make this a smooth event, so we couldn't do it without them. If your company is interested in being a sponsor, we have various tiers, and you can check out sort of the benefits of being a sponsor at that link below, CNCF Canada, myshopify.com, or if you go to the link tree, it'll be there as well. Here's our post-event survey. Again, we use the input from the community to make sure our events get better and better. So you can grab the link now, or you can grab it at the end. This is how you can give feedback to us as organizers, but also feedback to our speakers. Sometimes we get good feedback and we want to help speakers improve their talks. And so, help us be a community, help everybody level up as a speaker. And it's a short little survey, maybe only a few minutes. So it really, really helps. With that, I'm going to pass the mic off to Marino to talk about some CNCF stuff.
Thank you so much, Jason. All right, what do we have going on? KubeCon, Cloud Native Con Chicago. Who is going? Woo! All right, yeah, there are some of us here that are going to be speaking, so go take a look at the schedule. If you're planning on being there, maybe connect with some of us. Maybe we'll go hang out, grab some drinks, grab some coffee, whatever, and talk about some of the cool things we've learned at KubeCon. with that, we also know that the CFP for KubeCon EU is still open, and it's open until the end of November, November 26th. So get your talks in. You know, it's obviously a very competitive type of conference in terms of submissions, but there's so many different tracks, right? Maybe jump to a different track that maybe you never really ventured into before, and you might have luck there. I got rejected from KubeCon, but luckily enough, there's Cloud Native Con or the Colo events that also occur. And if you apply to those, you actually have a higher chance. And I like those conferences a lot more because they're smaller, much more focused. You have like the attendance of probably like 200-300 people that show up to your room, and they're in that same room all day. So you know, that's a great place to go out and speak and share something a little bit more specific to a technology area that you're passionate about. CFPs are open again until November 26th, and it's going to be slightly chilly, I think, in Paris around that time. So I'm kind of looking forward to the croissants and wearing a coat. Also, the Istio Certified Associate has just been launched. It's a certification exam, which is multiple choice, and I believe there is some hands-on. I had no part in it, but I found out about it not too long ago. But it's a certification that focuses in on service mesh. How many of you use a service mesh today? How many of you use Istio today? Oh, excellent. That's always good to hear. Istio is a brilliant service mesh. Anyways, the certification covers a lot of the fundamentals around traffic management, observability, using security with authorization, MTLS, and even authentication. So there's a lot of areas to cover. There are a lot of different available offerings and courses out there. The CNCF has some great courses to talk about service mesh and teach you all the cool things. There are some great YouTube tutorials. Solo, the company I work for, has some great workshops that you should go check out if you're interested in the certification. Some of you might have taken the CKA or CKAD or something like that. This would be the next step. All right, passing it back to Jason.
Yeah, unfortunately, sad news. Some of us had a chance to meet Chris or even see Chris talk, but we lost one of our strongest pioneers in the industry today, or not today, but recently. Chris Nova unfortunately passed away recently, and you might have known her from some of her cluster fudge talks or cloud native infrastructure work that she's been doing. She's got some books. In fact, Cloud Native Infrastructure is one of her O'Reilly books is amazing. Hacking Capitalism is amazing. And her recent work on the Ore runtime, all really, really amazing stuff. She's just a big part of the community. Things like her Twitch stream are just amazing to watch. So unfortunately, we lost Chris, but you know, she does so much and there's so much to just appreciate her work and respect the things she's put in. So cheers to Chris. I don't know if folks have a beverage or just maybe a round of applause for Chris, because let's celebrate all that she did. So thank you, Chris. We'll definitely miss you. All right, with that, let's jump into our talks for tonight. So first up, I'd love to introduce Kayla Murray and Leo Lee, both working with Red Hat now. Exciting place to be, and they're going to talk to us tonight how to build cloud-native event-driven applications with Knative. Let's give it a round of applause for the two of them.
Hello? Okay, I guess I'm just hiding back here, but I'll be able to speak, and Leo will be the face of our presentation today.
Thanks, Callum. Yeah.
So welcome to our talk. Today we're talking about how to build cloud-native, event-driven apps with Knative. As Jason said in the introduction, my name's Callum. I'm currently a software engineering intern at Red Hat.
And my name is Leo Lee, and I'm the software engineering intern at Red Hat as well, and working on the Knative eventing part, same as Callum. Oh, and this is our QR code for our lab demo, so you guys can scan it and join our Slack channel to view our amazing demo in real time. So let's get started.
Well, let's just take a couple seconds in case anyone wants to scan that QR code, maybe take a photo. If not, we'll be showing messages showing up in the Slack, but if anyone wants to see it for themselves, feel free to join. So yeah, Knative provides Kubernetes-based components so that we can do serverless computing. And event-driven applications really are a part of serverless as a concept. So let's start there for those of us who don't know what serverless is. What is serverless? if I asked, you'd probably mention AWS Lambda, which is sort of one of the big pioneering closed source technologies doing serverless. Maybe you'd mention something about scaling my computing down to 0. But really this scaling idea is like an entry point into a different programming model, a different way of building our applications. And when we look at the benefits of this way of building, we can see on the left, without serverless, we've got this kind of flat yellow bar of our servers. Maybe those are our the pods in our deployment. And then we've got that red line of the requests coming into our service. And we see that sometimes we don't have enough resources right at that spike for our requests, but a lot of the time we're actually spending a lot on resources which we aren't really using. And so when we move over to serverless, this starts tracking, and we have this line of usage and this line of requests, which are basically the same. And we can summarize this by an event triggers your application. So for example, a new order could be placed on Amazon, which would trigger the central order distribution system, and that would inform the people at the shipping area to package it. As an example, and this is what we're talking about when we're saying event-driven applications. Some event is driving my application to run. And as the different parts of my application run, they can also create more events, which then cause other things to run. And so I can make a complicated application very easily, and each of those parts can scale independently.
So we introduced four different components of Knative. So Knative serving, as Kellen mentioned, that is mainly providing the functionalities to scale up your containerized applications. It will scale up to 0 or scale up to scale it down to 0 or scale up to make it capable to receive enough traffic. And next is Knative eventing. Is our common structure infrastructure for consuming and producing events. So the magic is here. Knative eventing is capable to connect all different components seamlessly together within your application. Next, we have Knative functions. So as a developers, the only thing you wanted to focus on is developing your code, and you don't want to like get into trouble with deployments or any like scale up, scale down problem. So Knative functions will help you handle those part of things. And the next is Knative client. That is the interface for our developers to interact with Knative services. So developers will be able to, for example, create Knative resources or delete them, update them, etc. So next slide, please. So today our talk will be mainly focusing on Knative eventing, and with our prepared demo, we have used Knative serving and Knative functions.
So Leah, why are we focusing on eventing today?
Yes, Callum, that's a great question. So let's step back a little bit. So as you guys probably know from your programming experiences, we don't want to write the coupled code. So what is coupled code? So imagine like you have functions, and this function depends on other functions, and many different functions and modules are interdependent. They're all connected. So that's what caused a lot of problems. For example, the poor scalabilities. If you wanted to add a new feature to your functions, because other functions is interdependent with the function you wanted to make the change. So all of them need to be updated, right? So it's caused like a kind of butterfly effect. If you wanted to make this change, all the other things that's being connected need to be updated as well. And it's also really hard to maintain because all code is the code is hard coded and they're connected with each other, and also reduce the reusability for our code. So that's might cause a lot of like code reusability, a lot of repetitive code in our code base, and it's resistant to change because it's already there and it's hard coded, and that's what caused a lot of pain to our developers to get onboarded. For a new developer, it's hard to read the code. So this all of these disadvantages apply to the coupled service as well. But here we have Knative eventing as a solution to help you to reduce the coupling in your applications.
So yeah, so today we're going to be demonstrating how Knative eventing can reduce coupling in your system by working to build a full system, which will have 2 services or Knative functions, which are doing some math. These are kind of simulating maybe your big machine learning model that's running something and taking a while. And then they're going to be sending them to Slack. And depending on the result of that computation, they'll be sending a different Slack message. You can follow along with all of these demos at the GitHub repository there, where all the source code can be found. We're going to start with a single service and build our way up to the full system. And as we go through this, we're going to see what problems come up, where this code coupling can happen, and how Knative eventing can solve those issues.
Yeah, so let's get started. So as you can see here, this is a single service. On the left, we have the producer, which is a user. It's trying to call a function, which is service. And in this service, we have a function. The function is used to calculate the math expression. As you can see, this is our this is part of JavaScript code that's used to describe our service. So at the top, as you can see, const f, that function is used to calculate the result of this math expression. And in the bottom, there is like a return new cloud events, and it will put the result of that math expression into the data field in the cloud events. So some of you guys may ask, what is cloud events? So cloud events is an open source standard, open for to define the data format to be sent into the cloud native applications. As you can see here, we're returning that standardized object. So Callum, do you want to get started with our demo?
Yeah, so let's move over into our demo. Currently, this is just an empty cluster running with just Knative installed. So if we go into our first demo,
Callum,
zoom in a bit, yeah. All right, so we're in our first demo, and all we're going to do is just deploy a single function, f of x. And we're going to use Knative functions to do this. And all I need to do is say func deploy, and we're going to build this as well, just to make sure we're using the correct image for this demo. And here, it's building our function image. This might take a couple seconds, pushing it to Docker, and then it's going to deploy it as a Knative service into our cluster. And as we go through these, as we get to more complicated systems, this might take a bit of time, and Leo will be happy to take any questions from the audience as this builds.
Feel free to ask any question. Yes. So this is actually a Docker image behind the scene. Yes. The class is running on our local computer by using Minikube. Yes. For this demo, there's no queue inside our demo. Oh. So you mean how the event will be processed? Yes, it will. Oh, so that's what we're going to talk next. Yeah.
So we've deployed at this point. So let's just show that our function's working, and then we're going to be able to move on to adding in some more parts, some more services into the system. So we're going to use a value of x equals 5. And we're using func invoke here, which all this is going to do is create a cloud event and send it into my function as sort of a convenient way. I could also use curl, but this is a nice convenient way, and we can also show off a bit of Knative functions here. So it's going to take a second to make the cloud event, send it into the system, and then we're going to get our result back in the terminal hopefully soon. Looks like nothing happened, but apparently it worked. Normally it does. This is kind of the fun part where the demo doesn't quite work. So I guess nothing happened there. Interesting. Apparently there's no pods. Normally that should have created a pod. So we see we've got our service, but for some reason that didn't send anything to our service. So that's new. I guess for now, we can just move on to the second demo and hope that the second demo works a bit better.
Yeah, thanks, Callum. So next, if we wanted to add a second service, for example, after we have the result from the calculation, we wanted to pass it to Slack. We want to send the result as a Slack message. So what should we do? Yeah, so as you can see from the code here, at the top, we add a new function called emit. And this function is used to pass the cloud event into our consumer service. As you can see here, Slack message.default, that is the address of our destination service. And the rest of the code stay the same, but at the second block, we are trying to call this function to emit the cloud event to our destination. So it's my favorite time, demo time, Callum.
And we're going to hope it works a bit better this time.
Yes.
So we're going to go over to our second demo here. And this time, instead of just doing the function deploy, we have an installation script just because there's two functions, makes it a bit easier for ourselves. And we also, as you can see, it created a secret that has a Slack token in it. Don't want to just put that in your code. So Knative functions, you can map secrets in as environment variables, just like you would into your deployment or anywhere else. So the Slack message is using an environment variable from the Slack token. And so this one built a bit faster. Maybe that's a good sign. We're going to try again. We're going to invoke our function. We're going to pass in some data. X, let's try 6. Maybe 6 will be a bit luckier than 5 today. And there we go.
Hey, let's go.
So that one, we got a response here. And if we come on over here, we've got the Slack message. So the result was 113. I don't really feel like doing math right now, but hopefully 6 squared times 3 plus 5 is equal to 113. Otherwise, we've got an issue here. So I don't know if anyone's picked up on it, but we accidentally caused some coupling in our system here, right in between our two services. We have hard-coded the URL, which means if I want to reuse the service with a different consumer, for example, interesting, our slides are frozen.
It's like the slides stuck there.
Oh, there we go. If I want to send it to GitHub, I would have to change the code, put a new URL in, and then build my new image and deploy it. And that's not ideal. Maybe I want to run this in different namespaces, run it on different clusters, and these are going to different consumers. And so we don't want to have to do this reconfiguration, this rebuilding every time. Luckily, Knative provides something called a sync binding, where I provide the destination reference. It inserts an environment variable into my code, and now I can just reuse this image many, many times, different clusters, different namespaces, different consumers. So at this point, we're going to hop back over to our demo, and we're going to show off this working as well. But I think I forgot to show how the code works. So here you can see we basically make a sync binding. You put a subject at the top, which is our service called f(x), and then you put a reference, which is another service called Slack message. And if I wanted to point this somewhere else, I could make another sync binding going somewhere else. So let's hope the good luck continues and we can keep our demo working. And once again, because there's more than one thing to build, we're just going to use an installation script to build everything. So
I think after that, you can clean the screen so that the command will go to the top of the screen.
Yeah, sure. So the install script actually builds everything from scratch every time, just to make it nice and easy if you try and run this yourself. But that's going to make it a little bit slower during our live demo, although things seem to be going pretty well today. So let's just clear our terminal and try invoking our function again. Does anyone from the audience want to pick the value of x this time?
Any numbers? 4. Thank you.
So once again, we got another Slack message, this time 53. But this time we could change which consumer we're going to. And here's just a bit more of the code. We changed it. It's just using the ksync environment variable now instead of that hard-coded URL. So this is great, but I only have to update that destination reference. However, if I wanted to send to a second service, in this case, we're also sending Slack messages to keep things simple. How would I do that? Well, I could change my reference to that second service, but now I'm not sending anything to the first service anymore. So how can I solve that problem? Leo, you're going to talk about the channel.
Oh yeah, sure. So here we're actually introducing the new called channel. So it allows our sources to be able to connect to more than 2 different services. So next slide, please. So different services will subscribe to our channel, and our channel, after channel receives the events message, it will broadcast to all the services that subscribe to the channel.
And yeah, so this also lets us have multiple producers now. If I want to have more than one producer of events in my system, I can have them all send to that same channel. And then I can also, once we introduce the channel, we're not at that one-to-one relationship anymore. We've got a many-to-many relationship between producers and consumers. So for the case of our demo, we've added in a second producer, which calculates f of y instead of f of x. And we also have added in a second service that sends a message to Slack. But this one looks in the message field. So first of all, we're using sync bindings again. These are connecting f of x and f of y to the channel. This channel has subscriptions to the Slack message service and to the Slack result service. And an example of one of these, it just checks if the first one checks if there's a result in the data field, if there's a number. And if it does, it's going to send a message like we've been seeing with the value of the result. What we've done to make this a little interesting, and this is slightly arbitrary, is we've decided that from now on, if the result is over 100, we are going to set the message field instead, and it's going to say that that result was over 100, and so it's too big. And so in that case, this result service won't send anything. But our Slack message service, which is checking if there was a message in the data field, will send a message. So let's move back to our demo. And we're going to deploy a channel and all these services. So this one might take a bit longer. So Leo, I would take a question from the audience now.
Any questions so far? Yes. Yeah, of course. So in this case, our Slack message sending is being packed to a Knative function. So as a developer, you can put your application, any applications you want, to a Knative function and deploy it as a service. And this allows you to send a message to your function, and you can do whatever you want. So here is just a demo case to show you how the message can be delivered.
Can you repeat the question, Leo, so that I can hear back here?
So are there any other use cases like other than delivering a message?
Yeah, so you can build all the different parts of your application with eventing and have them communicate through events rather than talking directly to each other. So oftentimes, in this case, for example, we're saying we finished calculating something, here's the result, and then anyone who cares about that result can go and do something about it. Maybe an order got processed and now you want to send an email, so your email service cares about that. But maybe you also want to check the payment for fraud, so your payment fraud model is now going to go and process that as well. So this is a way of really decoupling all the different pieces you're sending rather than just sending the Slack message. That's really a demo thing. But maybe you're listening to events that are saying some part of your deployment is failing, and so you want to know about that on Slack. So that could be an example of when using the Slack messaging could be useful. So we've worked now, so we're going to try and invoke our function again. And we're going to use f x equals 4, because that's a small number. And so hopefully we've got this result over here. Result is 53, once again. But if I make this 40, 40 squared is already over 100. So we're going to get a message showing us that it's greater than 100. So here, our two different consumers are both able to get events from that same producer. But what if I want to go and check that my second producer is also working? So here, we're going to use y. And this one's using sine of y times something. So I'm not totally sure what's going to get us over 100. But I guess we can find out if 40 does. So yes, that one was too large. And we can see result is greater than 100. So these two services are sending a different message just to show that we have two services running and it's actually reading out of that message field. And then if we try maybe make this 100, then we get a negative number. So that's not bigger than 100. And here we can see we've got two producers, two consumers, and the channel's making everything work really easily for us.
Yeah, so as Callum said, the channel will broadcast all the events that's received to all the services that subscribe to it. And on the service side, it will trying to handle, should I process this event or not? So all the responsibilities to doing this condition check is on the consumer side. So here we're introducing broker. So we only wanted the consumers to do their own job. So instead of like trying to figure out whether should I process message or not, their job should only be like forwarding the message. As long as they receive the message, they will forward it. So here we're introducing broker. Broker will route all the event it received according to the data in the events. So for example, in the events we have the field called too large equal to true. Our broker will use this condition to forward the message accordingly. As you can see here, trigger one, it have a one subscription service which can connect to the service one, and if it detects that the too large field is equal to false, it will pass a message to service one. And same for trigger 2. If it detects that the event contain too large equal to true, it will forward message to the second service. So that all the responsibilities will be removed from the consumer side to our broker, which make our application more decoupled.
And this way also, all of your services will only be running on events they should be running on. And so since Knative can scale them all down to 0, if there is any events that doesn't matter for your service, it'll get scaled down to 0 and you're not using resources for it anymore. So let's go back to our demo. This is our last demo for today. And let's see how things work with the broker. Once again, we're going to try installing it with our install script. This is going to take a minute. So Leah, would you like to grab another question?
Yeah, sure. Any question? Yes. Yes, Knative broker is one of the components in Knative framework. Yes, so we have Knative client that can help you to easily to deploy all the Knative resources.
There's also the code you need to write for a broker, and all the triggers is currently on the screen. The very top part is making the broker. And so to make a broker, all you need to do is like apply that 5-line YAML file with Knative eventing installed. To make the triggers, there's a bit more work. You need to specify which broker they have, provide a filter if you want to have them conditionally pass events along. If you don't put a filter, then just every event will get sent. And then there's a subscriber. So this is that exact same subscription you had for your channel, except now it's embedded inside a trigger. And at this point, we finished deploying everything. So we can try this all over again. We can invoke our functions, try value of x equals 4. We get 53 again. And we can keep going with these different values, maybe 25 for x. And this should get us too large is true. And so our result was greater than 100. And so what's great here is everything is working the same as before, except now my code doesn't need to check if it should be running. And my functions are only running, my services are only being used if the data is meant for them. So let's just try one value of y as well. And there we go. So that wraps up our demo for today, but this is where you can start thinking about your system. So all of these components we've shown today are composable within your system, and you can pick which tool you want to use where. If you're just dealing with wanting to reuse one image to send to multiple different places, you can choose to use a sync binding. If you want to conditionally send your events, then you can add a broker. If you just want something that will send from multiple consumers to multiple producers to multiple consumers, then you can use a channel. And you can send from a broker to another broker, or from a broker to a channel, from a channel to a broker, and you can make your system how you want. And if you're using Knative services for all of your services, those will get scaled up and then scaled back down to 0 whenever they're not being needed. So thanks for coming. We'll take questions now. I will come back up to the front and say hi to everyone again. And once again, if you are interested in the code, there's a GitHub link right there.
Thank you, guys. Let's give round of applause to some. Sorry, let's wait for them to come back. Yeah, sorry, you have a question?
Could you speak up a little bit? We can't quite hear you here. In terms of like message queues and other things like that, there are, first of all, a lot of backing services to Knative. So if you're thinking about some kind of like streaming service like Apache Kafka, one of the Knative versions actually is backed by Kafka, and you can choose what technology you want to use to back everything. But the advantage here to just consuming off of a queue yourself is we can figure out which ones of your services actually want those messages in the queue, and you don't need to manage multiple queues yourself. Knative will manage that all for you, and when you want, we'll send it to the right services. And again, if those are all Knative services, they'll get scaled up and down for you as well. That's just like a given that comes with Knative. So there's different versions of eventing. Today we used the most lightweight one, which is just an in-memory version of everything. So we weren't storing anything because that's really lightweight, great for running locally. If I wanted to do this in production, I would recommend the Eventing Kafka broker, which would actually manage like a Kafka cluster for you. It would create the topics you need. It would manage that for you, but you might need to use something like Strimzy to actually create the Kafka cluster for you.
Next question, which is like more like the I was going to ask if you have production example of this running in scale, but if you have like Kafka or something that's backing in, I guess it is pretty scalable. I guess another question I had is, does it actually create like some kind of CRD per event or anything that communities resources per event, or is it more like?
Not per event. Yeah. So events are just cloud events, which can be serialized into like HTTP, various other formats. They're part of the Cloud Events CNCF project, actually. We have some CRDs if you're caring about discoverability. We're currently working on adding in more discoverability around the types of events that are in your system. So that's currently like auto creation of those event types is an experimental alpha feature right now. And we're working to bring that through, get feedback on how that's working, and get a more stable version of some discoverability into what events are actually in your system. So if you have opinions on that, come talk to us on Slack and we can chat about that since we're currently trying to solve that.
Like say you have a kube control and you can actually query for events there? Like
yeah,
that kind of stuff?
So currently all of the built-in Knative sources, which we didn't show today, will actually they'll reconcile all the event types they're sending, and you can just query those like kubectl get event types dot eventing dot whatever, and you'll get all of them. Now, you can also create those all for your own cluster, and that's already like a state. I think it's a beta feature right now. What's alpha is us automatically creating them as events come into the system. So if you want to not worry about making them every time you make a new event type, we have an experimental feature where every time a broker or a channel gets an event, we'll create like a CRD for you for that.
Oh, okay. So do you have like I was just skimming through doc, but like I didn't really have time. Is there like some kind of audit logs that, or do I actually have to go to like implement something else to look at like Kafka queue or something?
In terms of the logs,
like audit logs, all the events that that happened before.
I don't personally know that. That one I don't know off the top of my head. We do have logging. I'm not sure if we're actually logging the information about every event. Probably on the broker ingress, which is one of the pods that's normally running, that would be recorded. But I don't know the answer to that one off the top of my head.
Oh, and then I guess if you're using Kafka as a backend queue, then can you do like something like delayed event, like something that stuff like temporal can handle? Like for example, you want to like run it every like 12 o'clock midnight every day, or like you want to run it like a week from now.
So we can handle that with we support like various other sources. So for example, you can have like a ping source that emits an event every like 12 hours, for example. And that's kind of one of the ways that we solve it. We solve that on the event source side rather than on the event processing side. So if you are emitting an event on a schedule, we'll process that when needed.
But like it's more like the events are just processed in order, more or less.
Optimally, again, Kafka doesn't always process in order. It depends on your choice.
Okay. And the last one is I was just looking at it. So the events are like there's some kind of protocol for the event messages, and it looks like it's using HTTP by default. So any reason why it doesn't support other like other protocol like protobuf or anything?
It does support protobuf as far as I know.
I see.
But at least some of the code I've seen seems to be doing protobuf stuff. I've always done it with HTTP. I've only been on the project for about 5 months now. So there might be something there that I'm not aware of. But some of the code does seem to have something for protobuf happening.
Cool. And the last one, sorry. Do you have any example, like a real world production example that you guys are actually using this for, or know of any that runs in scale?
I think there was an announcement a couple weeks ago about SVA in the EU using Knative eventing to do some stuff. If you go, I think CNCF had a blog piece about it. But besides that, I'm not sure off the top of my head.
Cool. Great presentation. Thank you so much.
Thank you. Do you have any other questions? Maybe just put your hand up so we can get a mic to you if anyone else has a question. There. Okay, cool. I don't know off the top of my head. I've worked on the event delivery side of things, so I don't know if I'm the right person to answer that. Dave here might know. He's one of the more senior people in Knative.
Yeah, I work on the streaming side, so cold start's always a problem unless you have your app running. So, and there's sort of there's a good slide someone in the community made called levels of warmth. If you control the whole stack, you can potentially even like snapshot existing apps running in memory and then like load them off and load them back on. Knative doesn't do that. There's other hacks that like I wouldn't call it a hack anymore, where a lot of cold start latency comes from image pulls. So you can see Cloud Run under this feature, also to GKE like image streaming, where they kind of profile what files are used when a container touches an image or a container reads from disk, I guess. And then next time you pull the image, they just pull those files down first, type of thing. So there's like a huge, I would say, opportunity to increase cold start, and each of them is like a huge research project. And unfortunately, there's not enough time and contributors. So, yeah, that's my answer.
Do we have any more questions? Cool, I guess
that wraps up our talk. Thank you so much for coming.
All right. I think an extra round of applause for Callum for doing it from the corner of the AV closet is needed. That's not an easy feat. All right. So let's take this moment to stretch some legs, use the washroom, grab a beverage, and then we'll hop into our next talk in about 5-10 minutes. All right. So yeah, let's have a quick break.
Hello.
All right. Okay. So on to our second talk. I have the pleasure of introducing Adriana, who is one of our CNCF ambassadors, but also special guest Hannah. So for this talk, translating troubleshooting skills from baking to software, let's give it a hand for Adriana and Hannah.
Thank you so much. Welcome to From Cake to Code. We're super happy to be here today. Now, before we get started, let us tell you a little bit about ourselves. If the clicker would work. Come on, clicker. Fine. All right, it hates me. Why is it not going?
Technology, am I right?
Oh, what is going on? Oh, sorry.
Yeah.
All right, cool. Hey, my name is Adriana Villela, and I love solving hard problems, whether it's as part of my day job, which is a senior developer advocate at Lightstep, or on a rock wall, which is where you will find me blowing off steam when I'm not at work. I blow off steam a lot at the climbing gym. I'm also a CNCF ambassador. I am a second-year HashiCorp ambassador. I've got a podcast called Geeking Out that Hannah and I work on together. I'm the host and she does all the behind-the-scenes stuff. And I have been doing the computer things for about 20 years plus, which makes me old.
Okay, so my name is Hannah Maxwell. I like to bake, do art, and just like anything that involves creativity. I also boulder like my mom. I want to be a dentist when I grow up, not a computer. I think that makes her very upset.
It doesn't make me upset.
And I am also the Geeking Out podcast producer, graphic designer, and editor. So the cappies in the beginning I designed for the podcast, and I do the editing behind the scenes for the YouTube videos.
Yep, she's available for hire.
Yes. I also do not really enjoy computer things, unfortunately.
Even though she's taking a computer course this semester, which is hilarious.
I'm just a high school student, a very overdressed one, may I say. But yeah, I'm not into computers.
But yet here we are,
yeah,
doing a tech talk, alas. So why are we here? Why do we have computer person, non-computer person? So picture this, you're writing code. We've all been through it. You write your code, you spent all this time writing it, you go to run it, and it totally fails on you. And that happens more often than not. And sometimes, if you're lucky enough, the code will work right off the bat, which is awesome. If that happens, gold star, pat on the back, buy yourself a lottery ticket. Fortunately, it doesn't happen as often as we would like it to do.
So you're probably like, why are we here? Like, there's this person who doesn't even know what this is about. I really do not understand what anyone is talking about. Something about clouds and letters, stuff like that. But the reason I'm here is because it turns out there are many parallels between baking and code. And one of the main parallels between that is troubleshooting. Baking and code both go through a long process of troubleshooting to get the perfect final product. So today we'll go on a little journey of my troubleshooting experience making macrons and how that relates to this whole computer thing.
Yes. So here we go. Ready?
So troubleshooting is really, really hard, whether it's rock climbing like this, baking, coding, or literally anything else. So many things require troubleshooting, and it's a stressful and lengthy process.
Oh, tell me about it. Like, I mean, hands up if you've gotten mad at your code before. Number of times that I've wanted to, punch my screen, throw my computer out a window, throw a fit saying, what? King. I mean, it's one of those things that's super annoying.
Yeah, and I can totally relate to that on the baking front. There have been many times where I have stabbed the cake with the spatula or punched my macarons because it wasn't working. I can get really frustrated making macarons and baking, and it's so freaking annoying. You think you're like doing well, you're so close to the final product, and then it just all blows up in your face. You think you're taking a step forward finally, and then 5 steps back.
Yep. Really sucks.
Really.
So before we get into the macaron stuff and how, troubleshooting macaron relates to troubleshooting code, Chef Hannah is going what a macaron is, just for your reference.
Okay, so this is not a cooking talk, so I will not go into too much detail. But so this is macaron, made by me, just
photographed by me.
Yes. So these are macarons. First of all, they are macarons, not macaroons. Those are a different thing. They're macarons, not macaroons. No, these are a French. Well, they're originally French, kind of fancy meringues with almond flour in them. And so a little anatomy of macarons. This is the shell up here, and they're filled with anything you really want. But the important part is that they're smooth and they have this little like wiggly thing at the bottom. Those are called feet. And that basically tells you if it's a successful macaron.
Yes, absolutely. So now that we understand macarons.
So here's our little story. So since we've never made macarons before, we need a recipe, right? Like anything. No matter what you're doing, you usually need instructions if you've never done it before.
Totally.
And we sort of followed it.
Sort of, because I mean, we made meringues before. How hard can making macarons possibly be, right? We're pros at that stuff.
Yeah, so obviously we knew what we were doing.
So yeah, we sort of follow the recipe. It's kind of like in coding when, picture this, you're writing some code and you've got to integrate some like new library or you're learning some new technology and you're like frantically in the middle of the night looking through Stack Overflow and you're skimming through, the questions and the answers and various documentation. You're like, yeah, I kind of get it. So you sloppily integrate it into your code. And of course it doesn't work. Whoops. That's what happens when you don't read instructions properly. So,
Yeah.
Going back to our macarons, what happens when you don't follow the recipe for macaron?
Well, you end up with this beauty.
It's
Obviously,
beautiful.
they are not what that picture was that I showed you as a reference. It didn't help that we used blue food coloring because the browning of the oven kind of turned them barf green. But yeah, these are definitely no macarons. They don't have the feet. They don't have the smooth shell.
They were tasty though.
Yes.
They were
But
delicious.
obviously, it did not work.
So we tried to salvage them by, doodling on them with edible marker.
Not real marker. That would be
Yes.
bad.
Yeah, so behold the ugly macarons. So next step,
So clearly there was a problem with the recipe, right? Because
obviously.
we're great
The
bakers.
recipe was flawed.
Yeah.
We'd never done this
We-
before, but the recipe was
We are the world's greatest bakers. How could we mess up? So we tried again and we changed pretty much nothing. And so as you would expect with any science experiment where you change nothing, we failed again.
same result, just like with code. You ever write some code, execute it, it fails, and you're like, nah. Obviously the computer is wrong. I'm going to run it again. Obviously the next time it's going to run perfectly. Obviously not. Same sort of deal. So, with the macarons, after our lovely lesson of trying again and not following the recipe again, we decided to try something new. We decided to follow the recipe.
My God.
Holy cow. So what happened?
Yeah, so this time we were getting closer, but they still weren't quite there. We had the kind of texture of a macaron, but it still was not anything like we wanted it to. And we wanted to improve, but it still looks kind of wonky. This is where in troubleshooting, Google is your best friend. Read blog posts, watch videos, whatever you want. You know that part of the recipe that you skip through that has how they found the recipe in their grandma's trunk at the bottom of the sea? That part can sometimes be helpful when they're talking about all their experimenting. They actually put that in the recipe for a reason. So yeah, and also big thing, Google's not a person. So it is good to reach out to someone who has actually experienced what you're experiencing and done it before. I reached out to a friend who gave me the recipe and she helped me fix some of my problems.
Absolutely. And guess what? Similar deal in coding, right? Google is your buddy. Google helps you find those Stack Overflow posts. It helps you find the videos if you're a video person. Now, half of the fun, I'll put that in air quotes, of Googling is trying to figure out what question to ask, right? And so once you've figured out the question to ask, then you have the other part, which is, do I have one problem or multiple problems that I'm trying to troubleshoot? So that's part of the process, whether it's baking macarons or troubleshooting code. So, you know, ask the Google, do some research, but also just like Hannah said, you know, she reached out to her baker friend for help. It's okay to phone a friend if you're stuck with the coding problems, right? Hey, it's nice to have friends in high places. If you have friends that are experts in a particular area, or maybe there's a Slack community that you're a part of where you can ask questions. I'm part of the open telemetry community and I'm constantly asking questions on their various Slack channels because I'm always stuck, but people are nice enough to answer. Look at that.
Yeah, and all that Googling actually paid off because we found out that we didn't turn the conduction fan on, which is a critical thing for gas ovens, which was what we were baking the macarons in. A conduction fan just evens out the temperature, and macarons are so finicky, they need to have the temperature perfectly even. But that is where Google really helped us on
Absolutely.
our first big step.
Yeah,
So
and compared to like, you know, pro tip, if you're using an electric oven, you're not supposed to use the convection fan.
Well, it won't hurt,
but it's not like as critical,
yeah,
I
in a
guess,
gas oven,
compared to
it's
the
really
gas
critical.
oven. Yeah, so there you go.
So we did that, and we ended up with this semi-beauty.
Look at that. It looks like a macaron. Oh my God.
Yeah, and so we were so happy, and we thought we had got it. So then we
Tried it again.
Yeah, we're like, okay, I want another batch. So we tried it again, and spoiler, it was not repeatable. And
Nope.
I think that was when I had my first macaron punch.
Yeah, she was getting pretty desperate. I think we were like on the 4th or 5th try at this point.
Yeah, so it is back to the drawing boards, as the people say.
Yes, absolutely. So, you know, similar with code, it's one of those things where things may appear to work the first time, right? Maybe your code works the first time, the 10th time, the 100th time, and then all of a sudden, the 101st time, it blows up. And of course, you're in that state of disbelief of like, but we were friends, like, well, we're working now. Like, this is just so mean. But well, guess what? It's a sign that your code was not actually working, right? You've hit some weird ass edge case that you now have to take care of. But just like we persevere with our code, we persevere with our baking.
Yes, we really did have to persevere. I was so mad, especially because whenever I make macarons
So
with
mad.
friends, they do it on their first try, and I still can't seem to make it repeatable.
She'd give macaron lessons over Zoom.
And they come out perfect, even though they made a bunch of mistakes.
And she was crying at home to me.
Yes.
Why did they look ugly?
Either way, we persevered even though we wanted to scream and cry.
Absolutely. Yep, totally sounds like me when I'm coding. Do not get near me when I'm coding. It's a good thing that there is like a floor that separates my husband and me at home when we're working.
She's scary.
True. Very true. But all of our perseverance paid off, right? Because
we ended up with this guy.
Hey,
And like
again.
Even though it isn't the most beautiful macaron and maybe not textbook, it was repeatable. We had a solid base, and that was a win for us because sometimes you just need a solid base to get started, and then that's when you can refine. If you just go way into the refining, it's going to take so hard to make it the way you want it all the time. But we had a solid base, and it kind of reminds me of a quote that I heard once. An amateur does it till they can get it right, but an expert does it till they can't get it wrong. And we wanted to make it so we couldn't get it wrong no matter what we did.
Absolutely. Yeah. It's all about getting the baseline thing working, whether it's macron or code. Don't focus on making it beautiful. The beautification comes later. And, we do want to make our code beautiful, but we do want to focus on making sure that it's repeatable, that you have, an ugly baby that works. And then we'll try to give your baby a makeover, right? So, we need to refine. And so we invest our time in refining so we get some beautiful macrons, right?
And so it was refining time as our macrons started to look a bit more like actual macrons that we were kind of happy with. It was time to improve on them and make them beautiful. So we experimented, Googled, and refined with colors, how to prevent cracking, how to make it so it was the exact thing we wanted. We had already gotten the base, but now it's time to make it what our original goal was. And it was just all about that Googling and experimenting and just refining to get what we wanted.
Yeah. And I think whenever you're refining, experimenting, you can't be afraid of the thing that you're doing. So don't be afraid of your baking. Don't be afraid of your code. Sometimes you may break stuff while you're refining, and that's totally okay,
We've
right?
done that many times.
Many times. Me too. I go refactor some code. I'm like, oh no, but we were friends. You were working before. And of course it stops working and you're sad, but you're fine, and you learn and you learn and you learn as you make mistakes, and until you have beautiful code or beautiful macrons.
Yeah.
Which then takes us to another point that I think is really important as part of our journey, which is
don't be afraid of the do-over. This is one of the hardest lessons that I had to learn on my macron journey of troubleshooting. Don't be afraid to scrap what you've done. Start with a clean slate. In my case, I'd been using a recipe, and after multiple tries, I'm like, this is just not working out. It's not repeatable enough. I'm not getting it the way I wanted. So I can switch to a completely different recipe and a completely different method. I went from the French macron method to the Swiss method. And this is not a baking show, or else I go way into this, but just know that it's different. But the good thing about do-overs is you're not losing all that knowledge that you learned from your first try. You're taking that knowledge. Like, I learned how to make them not crack, how to do good colors. And I brought that into my new recipe, and that ended up working so much better, as although it kind of crushed me to get rid of all that hard work and all that knowledge I knew about the French method. It felt so much better to kind of just do it over and make it beautiful.
Absolutely. And similar to code, sometimes you're working on code, right? And all of a sudden you find yourself looking at the spaghetti of code. It's like, you're like, what happened? Like, this thing is the most horrible thing. You've got Band-Aids and duct tape on your code. You don't even know what's going on anymore, right? So the best thing you can do for, your code and for your sanity is to code side. You don't have to delete where you can't see, and then start anew. And like Hannah said, it's not a totally fresh start, right? Because along the journey, we've learned some important lessons that we can implement into our brand new fresh code to make it better the second time around. And it's worth that investment. Sometimes you just, quit so that you can restart and come back refreshed.
Like, what I like to say is that it's like you're building a tower out of like straws or sticks, whatever you want to imagine. And you're building it, but every time you keep adding another layer, it just keeps breaking. So you have to add more duct tape, more glue, just everything to try to stick it together. But then you look at it and you're like, that's not pretty. I don't like what it looks like. And this is just so much effort. So you really build over again. But now you know that each time you put a new layer on, this is going to break. You know that, this particular one, I should reinforce earlier because I know that it's going to have a lot of pressure on it.
Absolutely. So we've got some really good learnings. And from all that, finally, we got beautiful, repeatable, delicious macarons.
So finally, after many attempts, many different sessions of Googling, many cryings, many macarons punched, many macarons burned, everything. We finally got success, and something that we were proud of, and most importantly was repeatable.
And edible.
Yes.
Yes, we were very proud, and this took us about a year of experimenting.
I think even more.
Yeah, kind of
It
feels
felt
like
longer.
yeah. So yes, the fruits of our labor, success at last. So what have we learned today?
Okay,
First of all,
so read the freaking manual. Yes, you don't have to look over all that stuff when you're just trying to get to the recipe, but or even with code stuff. I don't know if you guys use a recipe or something, but just at least read what they've given you. They've made this for a reason. They have gone through the exact same thing with that you have, and you may think, oh yeah, well I know this or I know something like this, but it doesn't take as much time to read the manual as it does to experiment over and over and waste a few attempts.
and then go back to the manual anyway.
Yeah.
Next one is be persistent. Don't give up. My motto is I will not be beaten by technology, and Hannah won't be beaten by macarons. Persistence does pay off. Sometimes you need to take a little break and step away and clear your head, but don't give up, especially when you know it's doable.
Yes, and also try to understand why, because if you understand why something's happening, you're going to be able to build more on that, and you're just going to have more overall knowledge when you go into the refining stage. If I didn't know why I need to turn on the convection oven, then I would have probably been so clueless when going into the rest of it. It's like just getting an answer for a math problem, but not knowing how you get there. So when you go into the next math problem that's very similar, you're like, I know the answer for the other one, but I don't know how I got there. So what do I do now?
Absolutely.
So just try to understand why. It's going to really help you in the long run.
Totally. And also make sure you refine, right? You've got the base thing working. Now it's time to make your baking or your code more beautiful so that future you won't be looking at the code 2 weeks later and go, what the fuck was I thinking?
And not just more beautiful, but more, what's the word? Oh no. Mind block. Just easier to overall do, more efficient.
More efficient, yes, absolutely.
Okay,
And
and
then
the final one.
finally-
Yeah. This is the one that I think I learned the most from. It's just don't be afraid of the do-over. You may think, oh, I know this, and I don't want to let it go. I know all this information and I don't know if this will work, but the do-over is just, there's something fresh about it.
Liberating.
And if there's something that's not working, just try something else. And if that doesn't work, go back to what you know, but just don't be afraid of it.
Totally. And finally, I'm going to leave you with some Chef Hannah. Wow, this mic hates me. Here are some tips from the chef on what to avoid so that you can be successful.
Yes, also, I don't suggest making macarons. It is a very mentally stressing process.
She almost made them yesterday, but then she got too stressed out and she's like, nah.
Yes, so first off, water is your enemy. Just avoid water, water in your piping bag, water in your bowl. It will ruin everything. Macarons are so finicky.
For real. I had water in a piping bag once. She got so mad at me because our macarons ended up soggy.
Yeah, it's like a teenager. You do one thing and they're all just like, bleh, bleh. Okay, next up, use gel or powdered food coloring. The regular food coloring that you get at the grocery store is water-based, and that will just mess it up. As I said, water is your enemy. Just don't mess with it, please. I'm trying to save you all this time that I had to go through. So, and also powdered food coloring and gel food coloring just end up with better colors.
Absolutely.
Okay, use a tray that conducts heat slowly. There are people who can explain this way better than me, but macarons want even heat. So if you do a tray that conducts heat too fast, it's just gonna blow up and crack. Not actually blow up, but just it's not gonna be good. So you want to use a tray that's thicker, is a material that conducts heat slower, or even the liner of your pan. You can use a Silpat, which has fiberglass in it, so that'll slow down the heat conduction.
Instead of parchment paper.
Yes.
And finally,
stay calm. As I said, I have probably punched many baking goods because they did not work out. And if someone told me to stay calm while I was making it, I would probably punch them in the face. But honestly, staying calm is probably the best way that you're going to get something that you're happy with, because your attitude going in definitely reflects in your final product.
Whether it's baking or coding.
Yeah, no matter what.
Angry coding looks very horrible sometimes. All right. Well, before we wrap up, I always like to finish off my blog posts or my talks with pictures of cute animals. And since this is a capybara themed presentation, this is a picture of a real live capybara taken at the High Park Zoo.
We named our Princess Cappy.
Yes. Totally recommend that you go check them out at the High Park Zoo. It's free and they're so cute.
They are.
Also, the images of the capybaras that you saw,
Except on the first slide.
except on the first slide that you saw today, are generated from DALL-E. All hail our evil AI overlords. Because I put the slides together while Hannah was at school. Otherwise, she probably would have drawn those cappies for us. But I do want to mention that Hannah wanted to say that this one was not drawn by a robot. This was painted by her. So
I've been trying to get her to put it in a slide forever. So
there you go.
Finally,
I finally relented and said, hey, there it is.
Yeah.
Also, for anyone who is foolish to attempt to try to make
Don't.
macarons, this is the recipe that doesn't suck. It's one that uses the Swiss method.
The do-over one.
Yes, the
You
do-over
can also
one.
talk to me if you want tips, because I can probably write an entire book.
Yes, or a blog post with
No,
the
no,
of
I
the
don't-
recipe found in the trunk at the bottom of the ocean.
but I don't write.
Also, please check out the podcast that we do together called Geeking Out.
It's really cool.
I host it and Hannah does all the behind the scenes work, and she does appear with me in the first episode. We are available on all the streaming apps or on YouTube if you do not like to do podcasts.
And it took so long to edit. So, you know, if you want to look
And
at
I'm
it.
always on her ass over editing the episodes.
Yeah,
She's regretting working for me.
sometimes.
And then finally, please be sure to follow us on the socials. I am pretty much on all the socials. Hannah is definitely a Gen Zer who is only on Instagram.
No, Gen Zer would be on TikTok. I don't
that's
know.
true.
how
Oh yeah,
TikTok
that's true.
works.
She rejects
I
TikTok.
just got Snapchat and I have no idea how it works. Also, this is our beautiful Cappy that I drew. Her name is
Penelope.
Melanie.
Melanie. One's called Melanie, the other one's Penelope. We're not sure
Yes.
who's who. Also, if you're going to be at KubeCon, I will be there. I'm doing 2 talks, one for Observability Day on observability, obviously, and one on platform engineering. Would love to see you on there at KubeCon if you happen to be going. So that is that for us, right?
Yep. Until next time,
Peace out and geek out.
Does anyone have any questions? Macron or coding related, or just anything? No, I was going to, but they're just so stressful. Macarons are actually a different type of dessert. They are coconut based, although very delicious. Macaron is how you pronounce this specific dessert, and I know many people have messed it up. So here, this is me to clarify.
Totally different, like
Yeah,
different texture even.
yeah.
Both delicious, but
I have a question.
Yes.
I think a lot of what we do when we troubleshoot, we have a team that we fall back on, but we usually want to share our learnings so that people don't fall in the same holes. What are your tips for like sharing your learnings for troubleshooting?
blogger. My favorite medium for sharing troubleshooting tips is through blogging. I actually have a blog on Medium. So check it out. It's adri-v.medium.com. Because like, let's face it, it's so annoying when you've got a problem and you're like, I don't know about you, but oftentimes I feel like the problem that I have is like, I'm the only person who has that problem. Nobody else has had that problem. Like maybe some people have had like little bits of the problem that I can like pick out. And so when I discover like these funky use cases that, you know, I have like, you know, died just trying to figure out how to troubleshoot. Like, I want to share them with the world. My philosophy also is, especially with technical blog posts, is be as detailed as possible, because my biggest pet peeve with documentation is when you start reading like a technical post and the person starts, writing stuff, and then halfway through they're like, I'm bored with this. Oh my God. And it feels like those old days in like, high school where you're doing the math proofs and they're like, we'll leave the proof up to the reader. And you're like, fuck. No. So my philosophy is like, share all the gory details because everyone's going to benefit from it.
Yeah.
Teammates are like, I got this. Like, look, it's totally fine. I'm like, I can relate super well to this. I think it's something that we all go through repeatedly in the tech world. And thanks for making it. Awesome.
Yeah, I understand what you're going through on the baking front. Like, I'd teach my friends and they would like mix the wrong way and do everything wrong, but still. Yeah, but like still end up with like such beautiful things, and yet I'm on my like 5th attempt and I can't figure it out.
Well, yeah. Even, like you're talking about the prompt engineering for those cappy pictures for this presentation, like to be able to get a consistent look and feel was so hard because like generally like OpenAI is all right for generating those images, but other times it would give me something where I'm like, what are you doing? And it's really tricky, and you've only got so many free credits left before you have to start paying, and I for one do not want to pay it yet.
Yeah. Anything else?
Thank you.
Thank you. Thank goodness we're done. I'm past my bedtime.
All right, we're going to hop into the next one right away. And we've got Marina Weidre coming up with What's Smoother Than Your Morning Espresso Poll, Bridging Gaps with BGP and Cilium. Let's give a round of applause for Marina.
Yeah, now it's working. Okay, perfect. Okay, all right. Yep. Yeah, you're right.
Yeah, just leave it here. You can still clip it.
That was How's that? Is it okay? Good. Ready to go? All right. Sorry. Technical difficulties all night long. I kind of feel like I want to go baking right now. I know, right? Maybe I just might not work tomorrow and I might just bake all day. All right. So how many of you run BGP in your enterprise networks? Okay, like 2 people. All right. How many of you run Kubernetes? All right, lots of people. Okay.
I find that there's still some relevancy to this group of people that are here. Okay, so part of the reason I have this talk is because in a lot of enterprise and telco networks, there is a lot of transactions, a lot of different services and applications going on, and then you throw Kubernetes into the mix, and there's a new paradigm of how we get connectivity to those apps that live in Kubernetes. So there are so many ways that we can make this possible, but there are some traditional ways we can also make this possible. Enter BGP. We'll talk about what BGP is in a second, but let me introduce myself. My name is Marino Wijay. I am a platform/developer advocate at a company called Solo that focuses in on application networking from service mesh all the way down to CNI. That's enough about me. All right, let's talk about BGP and what it is. So in the world of networking, we have all of these interconnected devices. They need to find a way to be able to talk to each other. Simply, saying, hey, I want to be able to access this website won't be enough. You actually need to figure out the plumbing underneath to make that possible. So networks are built with multiple kinds of networks, with multiple networks meshed and connected together. But the way they're connected together is through these devices called routers, right? These routers are intermediary devices or gateways that connect all these different networks together and allow them to transact. But the interesting thing, though, is that we're not talking about this little diagram that you see here off onto the left, because that's just a very small chunk. That's a maybe 1/1,000,000th of what a network would look like in the grand scheme of things. So when we have a network 1,000,000 times that size, you start to think how one little entity finds its way across this entire network, how it knows to reach around the network, how it knows to navigate that network, but it doesn't have all the information. So when we have such huge networks, we need protocols, routing protocols to help us decide like how we learn about these other networks, how we go about connecting to other networks, how we go about trading information about networks we know about. And so BGP happens to be that protocol that does it, the Border Gateway Protocol. Now, you probably have heard of BGP in situations where Facebook went down or something happened on the internet that caused, like, I don't know, AWS to go down or something to that effect. And that's normally caused by a misconfiguration or something called route poisoning. But the reason that happens is because BGP is a public protocol. A lot of internet environments use it. A lot of service providers take advantage of it. And they build their networks using the Border Gateway Protocol. Now, the way this protocol works is it looks for the shortest path around the network using this path vector algorithm. I'm not going to describe the algorithm because we don't have enough time. Bellman-Ford, if you are familiar with that, right? Okay, because I know there are developers here who will probably study this stuff back in computer science. Anyways, different story. So it finds, like, packets find their way around the network based off of an algorithm that is basically looking for the shortest path. But with BGP, there are some things called attributes that help you influence the path. You might prefer to take a longer path because circuits, our physical wires, might be faster on that path. Whereas on the other hand, you might have a direct path, like two neighbors that talk to each other directly, but that link might be super slow, like a, I don't know, 10 meg link. So you have to think about optimizing the way your traffic gets around the network. But BGP as a protocol used both in data centers as well as in enterprise networks allow for a variety of ways to kind of recover around the network. So there's this thought process that if you operate a data center today, everything's running BGP. And the reason why everything is running BGP is because you have so many networks that you built that network information has to be shared rather quickly, and reconvergence of the network when there's a failure also has to happen in a timely manner as well. Anyways, why the hell do we even care about this? What is this relevant to us? Why is this relevant to us? So if we think back to some of the applications that exist in our environment, ones that cannot be containerized, cannot even be virtualized, they are bare metal, they're stuck with their IPs, they're stuck, that's it, we can't do anything more. What do? How do we connect them to our cloud native workloads? There are ways, right? But in a ever-changing environment, if you have environments that come up and come down and disappear and appear at any given time, you need a way to have a network to recover and accommodate for that. So
BGP can enter the world of Kubernetes pretty easily through different protocols, through different mechanisms. You could build it by hand if you want. But there is a technology out there called Cilium. How many of you have heard of the Cilium CNI? Excellent, excellent. How many of you know how the Cilium CNI works? Yeah, right, okay. So not to be confused with eBPF. eBPF is a technology that basically allows you to write sandbox-based programs that can attach itself to the kernel without having to recompile the kernel, but at the same time looks for events. It hooks itself into various possibilities for events that occur, and based off of those events, an action can take place. For example, I see a packet going from point A to point B. Well, let's block it. That's a simple eBPF program that we can build. Now, that technology has made its way into the world of networking because you can actually optimize the way we move packets around inside of a kernel because we can now make decisions at the kernel level. Because of that, we can also do filtering, we can block traffic, we can apply certain policy, we can see what's going on with latency, etc. But that's how the Cilium CNI works. It's how it operates and how it optimizes the packet flow. But one of the really cool features about this technology, about Cilium, is that it's well tuned to the world of networking. It actually was built with the network engineer in mind, because it pulls from a lot of the network engineering failures, successes, stories throughout the years, and brought this into the CNI world, brought this into the Kubernetes world. So when we think about the OSI model for a second, and don't worry, I have a demo that might not always work, but we'll see what happens. We have this OSI model, and we have to think about how we stack up and how we layer up. So in the world of cloud native, Kubernetes is our physical layer. It'll give us all what we need to actually just run something, but there's no logic to move traffic around. So we take that up a notch and we implement a CNI that allows us to give pods or containers a TCP/IP stack to be able to communicate to the outside world or to other services. And then if you want another layer of logic, you can throw on a service mesh so that your applications themselves have their own little network to communicate on. That's not what we're here to talk about. We're here to talk about the transport and network layer where Cilium lives and plays best. So Cilium has come a long way. In August, Cilium 1.14 was just released with a whole bunch of enhancements. It does it's a Swiss Army knife for a lot of things networking inside of Kubernetes. So you can take care of a lot of different use cases that you might need. For example, you might be looking to do a multi-cluster environment across multiple different locations. Cilium has technology called cluster mesh. You might be trying to implement load balancing internally for your cluster, for your services. It offers up load balancing using eBPF. It actually has something called the kube proxy replacement using eBPF. So you can turn on that mode so kube proxy isn't in line anymore. There are a whole bunch of other things as well that Cilium offers, but BGP is one key thing that it provides. So if you have an enterprise network that has legacy workloads and you're trying to bridge it to the world of Kubernetes, right? One of the really cool things that Cilium has offered up is building out a BGP control plane because it's a networking solution. So here's how it looks. Here's how it works. We have Cilium that might be deployed into a cluster, and you can look at it as this is your Kubernetes cluster. Anything, could be GKE, could be EKS, it could be kind. There are certain specific scenarios for how you would set this up in each one of those cloud providers, by the way. But let's just take a generic kind cluster where we have 2 nodes and a control plane node, 2 worker nodes and a control plane node. And then you've got Cilium layered on top. One thing that Cilium offers up is this custom resource definition called the Cilium BGP peering policy. I'll show you what it is later on. But it is actually a definition to say spin up routers and peer with your upstream routers so that we can exchange network information with the upstream world. And then outside entities can find us or find pods that live inside of Kubernetes. So there's some really cool things you can do where you can have multiple types of routers that might be serving different VRFs. What are VRFs? Virtual router forwarders. Those are heavily used in telco and service provider environments. In fact, I know Bell is doing something very similar to using multiple BGP peering policies to be able to achieve this. They did a talk last year about it. I think it's on KubeCon NA or no, it's like the colo event. Anyways, so you can actually customize the setup to like however you want to. But the idea is that you're actually instantiating virtual routers that will peer with your upstream router in BGP, and then the network information gets exchanged. Now, there's something interesting inside of the Cilium BGP agent where there's an agent that actually is watching for any sort of kube API processing of a Cilium BGP peering policy. If in that BGP peering policy, there's also a Cilium virtual router specified, that is then the indicator that we're going to neighbor up with someone upstream, and we should be able to exchange that network information. So this is what that BGP peering policy looks like, and I'll show you a little bit of this when I get into the demo environment. But we have one thing that I'll point out is if we actually go back to this environment here, each one of these nodes is considered a neighbor for this top of rack router. So if this is a BGP speaker, it would be a peer of this router up here. Same with this host as well, or node, I should say. So in this situation, what we're actually doing is we're looking for all the nodes in the cluster that we want to peer with. And then we're also going to go ahead and say we want to advertise our pod siders. And then we also want to advertise any sort of services in our cluster that might have we might want to expose to the outside world or to other networks or to those remote networks. So there's a few fields that we'll have to make sure that we maintain here, and then we should be good to go. Now, let's go to our demo because I want to get the hell out of here soon and get home because it's past my bedtime, actually. I'm usually in bed by this time, but y'all were coming out here, so I had to come out here too. So in my demo environment, what I just want to establish here is how the peering is going to be established. And I'll show you a little bit of how this is all set up. This is a Kubernetes cluster onto the right. And this is a free range router, FRR router. Are you familiar with that? It's a routing daemon that it's open source. There are technologies or vendors out there that use it underneath the hood for their own enterprise offering for any sort of gateway technology, but you can just pull it off the shelf and deploy it in Docker or as a virtual machine and use it as a full-fledged router. It supports like a wide array of protocols. Anyways, I have that QR code there because if you decide you want to follow along and test this out for yourself, I have all the configurations laid up there. I just have to sort them all out and give you a sequence to follow to make sure you get this all up and online. So let's pull up my demo environment and show you a couple of things. And I am basic when it comes to demo environments. I don't have anything. I don't have any of those fancy terminals. I'm not using K9s or anything like that. Why am I only sharing one tab? 1 second. Screen. Yeah, you know what? I'll just share the entire screen. It's all good. Okay. So I have this little cluster here. And I'm going to make this bigger so that you all can see. Looks good? Yeah? Okay, cool. So what you... -0 wide. So in this cluster, I've got, ooh, it doesn't look too nice. I've got 3 nodes, and I want you to pay attention to these IPs here, 172.1.3.37.3.2, and .4. These IPs are the neighbor IPs of these hosts. There's actually annotations that I've assigned to each one of these nodes to indicate that as such. So in the world of BGP, the way neighborships work is that one neighbor has a router ID, another neighbor has another router ID. As long as they decide to form a neighborship through TCP port 179, they'll exchange router ID informations and say, hey, I'm trying to peer with you, you're trying to peer with me. I'm going to store your information in my database. So I have to tell the upstream router that this is going to be the router ID it's going to peer with. So those are the nodes. Here's some workloads that are not really going to do anything because half the demo doesn't work. I'm sorry, y'all. I tried. Okay, so I've got the book info application, which if you've ever played with Istio, you'll probably find it somewhere hiding. But it's just a little application that allows you to test out some microservices. It's written in a few different languages. So I have my app running. They all have IPs. And you can see that here that, some are in the 10.242.1 subnet, others in the 10.242.2 subnet. So what that's indicating is each of these nodes has their own pod CIDR, their own specific pod CIDR that they're advertising, or they're going to advertise to the upstream top of rack router, which is my FRR router. Now I have Cilium installed as well, and if I do a kubectl, I'll get pods dash and kube system. I'm not using demo magic. I just like to type out my commands and torture myself. I've got Cilium running, and I've got operators. I've got the Cilium pods. Remember, these Cilium pods have the agents running that are looking for the Cilium BGP peering policy. So I actually have a router that I've instantiated. Where are you hiding? Okay, so this is the router. I'm actually in the bash shell of the router, so I can see the underlying Linux operating system. It's got an IP address of 172.11.0.2 and another IP address of 172.13.37.5. What that means is this router is dual homed to two different networks. So on one end, it's connecting to some client. On the other end, it's connecting to the Kubernetes cluster. So what's supposed to happen is the moment I turn up routing, I'm not in the routing application yet, but the moment I turn up routing, I should be able to start learning about the pod CIDRs from my Kubernetes cluster. So let's jump into the router app itself. So this console that I'm in is actually part of that bash shell. It's part of the actual FRR router. This is a process itself that's running routing. It's got BGP enabled, and if I do a show IP route, the only routes that I have is a default route and 2 connected routes. Yes, I absolutely can. Does that look better? Excellent. Okay. So what is a connected route? It's just that this router has a leg in one network and another leg in another leg in another network. And then we have a default route. If we're trying to get to the outside world, we'll hit this gateway. But I don't want to manually assign static routes every time I want to define where I'm trying to get to these remote networks. So this is why I use BGP. This is a very simple use case. Please don't replicate this in production. I'm telling you, I used Docker networks to build this all. It was a nightmare. It's not fun. If you're doing this in production, you're probably going to, don't call me. All right. So what I want to show y'all is that I'm going to deploy a Cilium BGP peering policy. So let me just clear my screen here, and I'm going to up arrow a bit. Yeah, that delete there was me testing it a few times before I came up here just to make sure that it was working. Okay, so before I run that command, I just want to show you all that, remember, there are no routes here, so I haven't learned anything. Actually, before I even run this command, I'm going to run Cilium BGP peers. And I don't have anything right now, because while the BGP control plane process has been enabled, I haven't configured it to do anything. So this BGP peering policy that I have up here, what it's effectively going to do for me is instantiate routers at every single node and then automatically peer to that upstream top of rack. I don't know why I ran the delete command. I meant to run the apply command. And here we go. So now if I run Cilium BGP peers, Cilium BGP peers. See, I told you it's my bedtime. I don't do well after a certain time. All right, so I see that session is established. That's actually a critical status to know about, because it means that the TCP communication has been established between the BGP peers. It means that the 2 peers will start exchanging networks. Things are good. If I see anything else, it could mean that there might be a firewall blocking. It could just mean that there's a misconfiguration in the peering configuration. It could mean a lot of things. But anything else but established means BGP is not working. Established, we're good to go. So if I actually go back to my, yes, this is my router. So if I do a show IP BGP, I'm actually learning about networks now. If I actually do a show IP route, I'm learning about networks from BGP. Why this is good is because notice here, I actually advertised a few different networks. These networks are the node siders, right? Each node has its own individual sider that assigns addresses to pods. And that just means that now any one of those pods, if I decided to ping it, I can't ping it. Well, actually, I should be able to ping it. I could reach those pods from my router. This address right here, why do I have 3 next hop addresses? Does anyone want to tell me that? Sorry, what's that? So I have 3 next hops for the same address, and it's actually a very direct address. This address is actually a service IP or a service address. So if we go back and do a kubectl get SVC, you see this external IP and its type is load balancer. So I assigned a Cilium IP pool load balancer pool configuration. You didn't see it, but it's there. And what that does is anytime I have a service that is looking for a load balancer IP, it'll pull an IP from that pool and assign it to that service. And then I can advertise that into BGP and share it upstream. So let's just say you had a bunch of microservices running inside of Kubernetes, and it was your production app now, and you had legacy workloads that needed to communicate with that. You would advertise your service IP out into BGP, out to the rest of your network, so other entities there can access it. That's how you would do it. So in our case, if I went back here, all this is telling me at this point is that now I can reach my service IP. I can't ping it, by the way. The reason why I can't ping it is it's an artificial IP. It's just a logical entity. It only responds to what's on the back end. So the only way to interact with it is with a curl. Unfortunately, FRR doesn't have the curl utility, so I can't show you that. What I can show you is that if I try to ping any of these, not from here, if I try to ping any of the pod IPs, because the pod IPs would fall in this, it should work, but I won't do it from, actually, can I ping? Yeah. 10.242.1. Let's go back and find. .242.1.21. I feel nervous about this. Oh, there we go. Okay, that worked. Okay, I was a little scared there for a second. I was a little scared. Okay, but what that's telling me is now, like, if I wanted to go into production and decide to do this at full scale, I absolutely can. The logic is there. The documentation isn't complete because the reality is there are very few customers that are doing this in production today. Bell happens to be one of them. In fact, I did mention they have a talk out there. Also, y'all were my guinea pigs for this talk because I have so much more I have to do to improve upon it in terms of flow, in terms of demo, completeness and whatnot, because I am presenting this at Cilium Con, and I actually will not be doing it in the flow I did. I'm doing the reverse, where I'm going to do demo all the way through because I want to be able to convey a whole bunch of different capabilities of the Cilium CNI and BGP. Anyways, that's it on this side. Let me take you back to my presentation. I actually have nothing else, y'all. I just want to really just show you all the QR code so I can tell you about Solo Academy. I got to plug Solo's Academy. The reason why is because there are a lot of fundamental open source technologies that there isn't like amazing training on. There's training, there's bits and pieces here and there. So the brilliant engineers at Solo came together and put together a whole bunch of open source tech education by way of workshops, like hands-on, go to Solo Academy, play with the stuff, and then get to the next level. By the way, there is some Istio training in here too, which will actually confidently adequately prepare you for the ICA that was just launched very recently. With that, that is the end. Any questions before I close up? Good. No questions. Okay. Damn it. Come on, Rick.
So what's the use case where you see router pods? Like where do you see them coming into play?
So there are situations like if you think about databases, right? Databases cannot be containerized. Well, it shouldn't be containerized. Technically, you can, although you shouldn't. There is a lot of thought process behind that. But in those situations, databases don't easily communicate with service IPs or DNS names in the way like Kubernetes would give them access to. So sometimes you have to just give them direct access to pods. Sometimes you have pods that cannot change at all. So you kind of need to have them like long-standing, and they might be providing a long-term service that simply just cannot be turned off. So in that's like a very corner case. Other situations are like you do have legacy applications that have been hard-coded with IPs, and you just can't change them unless you decide to refactor the entire damn thing. Also, in service provider networks, it's widely used to be able to create. I don't know how many of you are familiar with this concept of like layer 2 VPNs, but layer 2 VPNs create direct pathways between locations. So for example, if ecobee had another location somewhere elsewhere and you didn't want to take a physical wire over there, you would build a layer 2 VPN. With Cilium, you can actually provide a similar capability through it. So what some of the telcos are doing is using multi-protocol BGP and VRF technology to create those VPN connections for for their clients. So you could actually simulate these virtual networks on virtual networks. Cool. All right. Thank you so much. You want to close?
All right. Thanks, Marino. That's it. That's all the talks. Again, here's our survey. If you have feedback about this event, how we ran this event, or things we could have done to make this event even better, let us know through this survey. If you have feedback for the speakers tonight, so Callum and Leo still here. Adriana unfortunately had to go. Reno's still here. You can leave feedback for them through this survey, and we'll get them feedback through that as well. But otherwise, feel free to hang around for a bit. We have the space till 9. I will be around till 9. Michael Foster, what do you got? Yes, if yeah, both of those. And even beyond Q4, if you're unable to host for Q4, it's too soon. Q1, we're always looking. Please submit your interest in there, or even if you have questions about what it means to be a host or means to be a sponsor, let us know. We're happy to talk. Join us on our Slack channel. We're all there. Chances are, if we're able to get slides from our speakers, we'll probably distribute them there as well. So otherwise, have a great night. Thank you so much for coming, and we hope to see you at the next one.